Hello everyone, this is Kusmakar. Welcome to the series of C programming. So today we will discuss about the data types. So I will explain the data types with the programs. So I'm using the same program which I had used in the previous chapter. So if you want to understand this chapter with the program, then I will recommend you please go through my previous chapter, chapter number 3, where I have explained the input and output operation using this program. So I have written the same program here. So I will use the same program to explain the data types. So in this program I have commented all the data types with their range, with their format specifier and the range of value those support. Right, and it is the same program. Here I am getting printing the value to enter a number, then I am taking the value from the user, saving it in the memory location, and then I am giving the output that the entered number is the value which user has entered. Additionally, I have added one line here. So in this line I am printing the size of the variable using this function size of variable. So if the variable is of integer, then it will give the size of integer data type, right? So let's me explain about the data type. So there are three standard type of data. One is character, the decimal, and the integer. So these are the standard type of data which is to be stored in the memory location, right? So how compiler will identify that what type of data is compiler going to work. So there are some keywords which will tell the compiler that the type of data and the size of those and the value which can be saved in the memory location. For example, if I take the example of short. So short is the data type, or we can say keyword. So this data type support 2 byte of memory. Means for short variables we need 2 byte of memory, and in that memory this range of value can be saved. Okay. Now take the example of int. So if variable of int type, that means it required 4 byte of memory, and in that memory location this range of value can be saved. So here why I am saying the 4 byte, why not 2? Because it depends on the compiler. If compiler supports 2 byte of memory for int, then it will reserve only 2 byte of memory. So in code blocks its compilers support the 4 byte of memory for integer type. So that's why I am saying in code blocks int variable will need 4 byte of memory, and in that memory this range of values can be saved, right? Similarly for other data types as well. So for float it required the 4 byte of memory. For if any variable of float type, that means it required 4 byte of memory, and in that memory the decimal value will be saved, and that decimal value can have 6 decimal places. And if we want to use the bigger decimal values, then what we do, we will use the double data type. So if any variable which is of double type, then for that variable 8 byte of memory will be reserved, and in that memory location this range of value will be saved, and that value can support 15 decimal places, right? For character as well, character requires the character variable require 1 byte of memory, and in that memory the range of value can be saved. So that range we will discuss in the next chapter. So in this chapter we will discuss more about the integer. So short, unsigned int, unsigned short, long, unsigned, long. So all these support the integer values. Some supports the negative values as well, and some data types only support the positive. So unassigned always support the positive values only, but its range is greater than the data types which support the negative values as well. So if you want to use the bigger values which is in positive, so you should use the unassigned. Like let's say for int, it supports the negative values and the positive values as well. But unassigned int will support only the positive value, but its range will be higher than int values, right? So for float, you need, if you want to work with the decimal values, then you should declare the variable with the float type, and it support the 6 decimal places. So I hope it is clear to you now. Let me tell you the format specifier as well. So I hope you are clear about the size of the data types and the range of the value. Size means for the data type how much size of memory is required, and the range is what range of value can be saved in that memory location. Let me give you an example as well. Let's say if I declare float a, so what will happen? Float requires 4 byte of memory, so it will reserve 4 byte, right? Now it is reserved for float, and float a variable is the memory location name. So in this we will use the decimal values, and it can support the 6 decimal places. So like this, so 6 decimal places will be saved in this memory location if we are using float a, right? And its size is 4, and its range is defined, and we cannot use the value which is going out of this range, right? Let's say if I use int a, so int also support the 4 byte of memory, but it will not save the value with the decimal. So this number will be saved only, okay? Or 45 means any integer value without decimal values, right? So this is exactly happening. So I will show you with the help of program. Yes, I was supposed to tell you about the format specifier as well. So every data type has their own format specifier. So you have to always mention the format specifier for the data type which you are going to use in the program. So if you are using int, then you have to use the format specifier for int. Similarly for float, if you are working with the decimal values, and you have declared the variable with the float type, then you have to specify the format of float %f. So always remember to use, or always keep using this format specifier for the same data type which you are using in your program. Like in this program I have declared int n, so for n I'm always using the format specifier of %d, right? So we will start with the short. So I am declaring a variable n with the short type, right? So what I will do, I will use the format specifier for short, hd. So hd is the format specifier for short, this, right? Now see what will happen. So in this program I will also keep checking the range of values, right? So I have declared the short n means 2 byte of memory is required. So what will happen in memory? N is the name of memory location, and 2 byte of memory is required So what will happen? 2 byte will be reserved for n. Sorry. So this will happen in this line, 16 number line, short n, right? So let's run it. Now this range, now this space or this memory location of 2 byte can support the range of value which is defined here, 32767. So you can use maximum positive value of 32767. You cannot use 8 as well. Means you cannot go beyond this range, right? If you try to go beyond of this range, then it will not show you the correct value, because this memory location of 2 byte cannot save the value beyond this range. Let me show you how. First I will run the positive flow. Let's say this 32767. So it will be shown in the same manner. Means 32767. So entered number is 32767, right? And the size of n is short type, so its size is 2, right? So let's say if I use the value which cannot be saved in this memory location, then what will happen? Let's say I use 3276779. Okay, now see, so it cannot show the value which we have, because we are trying to save this number in the short memory location, the memory location of short type, and that memory location cannot save this range of value. So what will happen? That number will not be saved in that memory location, and the incorrect number or the some garbage value will be shown, right? So let's say if you want to use the value greater than this 32769, let's say you want to use this, so this data type cannot support this value. So what you have to do, you have to support some other data type. So there are some other data types like int, so it supports the positive value of this range. Okay, so you can change from short to int. Then you have to change the format specifier as well, right? Now you can use the value greater than this 32767. Okay, now I will use 3276753, which is much greater than the short range. Now you will see the correct value showing here, because the memory allocated by int is much greater than short, so it can save the value which is greater than the range of short. So its range is higher, so it can save the greater values, right? And here the size of n is 4, so 4 means 4 byte. Size of always show the size in bytes. So int having the 4 byte, so it will show the 4, right? Let's say, or in this case you could also use unsigned short, right? So you could also use the unsigned short. So in that case you have to use the format specifier unsigned short HU. So if you are using the unsigned short, that means you can use the range of value which is defined for unsigned short, means 65535. You can use this range of value, and only positive values can be saved. Negative value cannot be supported with the unsigned data type. right? So let me show you this. 65535 65535, right? That is showing correct. Let me run it again with the breaching value 65536. So I'm using greater value, so it will not show because unsigned it does not support the value greater than 65535. So I hope it is clear to you now that what range of value we can use with the data types for int. So for int in code blocks, int and long both have the same size, 4 bytes, long also having the 4 byte, and int also support the same range of value, and long also support the same range of value. So either you can use int or long in code blocks, so it depends on you. You can use any of the data type for integer, right? And if you want to use the bigger range of value in bigger range of positive values, then you can use the unsigned int as well or unsigned long. So whenever you are using the data type like unsigned int, then you have to use the same format specifier for that, right? Now this is all about the int. Now let me explain you about the float. Now float, you have to declare the data type of float, enter a number, then you will specify the format specifier for float here also, right? Now see, if so it supports only the decimal values, always remember. If you try to use the integer value, then that integer value will be converted into float because we are using the format specifier of float, right? Let's see, you enter 4, so 4 will be saved as 4.00. 4 will always be saved as with decimal, 6 decimal values, 6 decimal places. See, 4.000. So if you are using the float type, then value will be saved in with the decimal values always, right? Now let's say, so float range is this, and it's the size of memory for float type is 4 byte, and it can support the 6 decimal places. So if you want to use only 2 decimal places, then what you can do, you can mention dot 2, okay, or dot 3, so it will show only the 3 decimal places, and in this case it will show you only the 2 decimal places. Now let's see how. Let's say we have entered 3.456789, right? We are entered the number with the 6 decimal places, but we want to show with the 2 decimal places, so we will use dot 2. Now if you can see 3.46, so it will be formatted to 2 decimal places. This is the size of float. If you want to use the 4 decimal places, then you can mention dot 4. Now see, 3.123456. So here it will print only the value with the 4 decimal places, right? So this is about the float. So float cannot support the value with more than 6 decimal places. Means if you try to work with the 7 decimal places, then it will not work. Let's see how. Let's say you have entered 3 dot 1 2 3 4 5 6 7 8, right? Okay, sorry. Mhm, mhm. 3 dot 1 2 3 4 5 6 7 8 9. So here it is showing the 7 decimal places: 5 6 4 3 2. Okay. Now you can see 5 6 4 3 2 4 5, right? And here it is showing dot 5 6 4 3 2 3 4, which is incorrect. So it is not able to support 7 decimal values. It can support only 6 decimal places. Let me show you again. Let's say 33 dot 1 2 3 4 5 6 7 8 9. Now see what is showing here. 33 dot 1 2 3 4 5 5 0, which is incorrect. Where I have, it should show 1 2 3 4 5 6 7, which is not showing here. So float cannot support the value greater than 6 decimal places. So for that you have to use the double data type, because double data type can support 15 decimal places values and its range is higher than float. So what I will do, I will use the double. I will use the format specifier for double. Double format specifier is LF. Here also I will use LF. So it can support 15 decimal places, right? So if you want to use the bigger range of decimal values, then you should use the double. Now see, I will run it. Let's say if I enter 2 dot 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. Now see, it will show the exact correct value with 15 decimal places. 2 dot 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. So it is showing the correct value up to 15 decimal places. So I hope these type of data types clear to you now, and you can also understand means how should we work with these data types, and how much memory they required, and what range of value they can saved in that memory location which is reserved by these data types, right? Okay, now let me show you. Say if you want to comment a single line, then you can use the slash. Now see. Now see, let's say if we want to convert the value from int data type to float data type, then we can use this type of operations as well, like int a is equal to 2. So you can also mention the value directly when declaring the variable. So here I am declaring the variable and assigning the value as well. Then what I am doing, I am declaring the k variable and assigning the value of a. So a is having the integer value and k is a float type. So when we will assign the integer value to the float type, then that integer value will convert into the decimal places, then it will be assigned to k, right? So if we want to display the k, so what will happen? Now see, a is 2 but k is 2.00000, because first a will be converted into decimal, then it will be assigned to k, because k is a decimal variable of decimal data type, means float data type, right? So see, k is equal to 2.000, or you can show as well dot 2, so it will show you the decimal places with 2.00. Now see here, so in this manner you can assign the value of different data type to the another data type. So you can assign the int value to float. So when you are assigning it, that means that is converting into the assigned operator. So this is the assignment operator, right? So assignment operator means the right hand, the value at the right hand will be assigned to the left hand, right? So a value is assigned to k. So a is integer, so a will first it will be converted to decimal, then it will be assigned to k. Or we can say when we will assign 2 to k, then that value will be converted into decimal, because this k variable is a float type and float support only decimal value. So when we will print k, only the decimal value will be printed, right? So I hope it is clear to now. So this is all about the decimal places and decimal values and the integer values, and next chapter we will learn about the character variables and the character data types. Thanks for watching this. Please don't forget to subscribe our channel. If you have any query, then put down your query below. See you in the next chapter. Bye bye.